let's talk about the distance formula, which is the formula you see on your screen right now. You'll notice that it has a square root, so before we get started on learning anything new, let's review what we should already know about radicals. For example, what's the square root of 25? The answer is 5, because 5 times 5 equals 25. Essentially, when you're asked to square root something, you're just asking to figure out what times itself equals that number. What's the square root of 44? Well, there is no perfect answer. Unlike 25, that is the product of 5 and 5, or 16, that's 4 times 4, or 81, that's 9 times 9, 44 doesn't have a perfect square root. So you could give a decimal answer, or you could simplify the radical. To do that, you need to make what's called a factor tree. Draw an upside-down V, and then on either end of the V, write a number that multiplies to get to 44. For example, I could multiply 2 by something to get to 44, and that something that I would multiply 2 by is 22. 2 and 22 gives me 44. Okay, 2 doesn't break down any further. It's what we call a prime number. The only thing that I can multiply to get to 2 is 1 and 2. So that end of the branch is done. But 22 can break into 2 and 11. 2 times 11 gives me 22. I'll go ahead and cross off 22 because I broke it down. So looking at our new branches, 2 again is completely simplified. That's a prime number, and so is 11. The only thing that I can multiply to get to 11 is 1 and 11. So now that I've gotten a completed tree, I need to look for pairs. I see a pair of 2s, and I see a lonely 11. Since there are a pair of 2s, that's like saying 4, right? 2 times 2 is 4, and the square root of 4 is 2. So I could write a 2 on the outside of my radical. But 11 didn't have a partner. I can't square root 11, so 11 has to stay inside of the radical when I write the answer. So my answer would be 2 times the square root of 11. I had a pair of 2s, so I took the 2 outside. And I had a lonely 11, one that didn't have a partner, so it had to stay inside. 2 root 11 is the exact simplification of the square root of 44. You can also give a decimal approximation by just typing it into your calculator. Your calculator would tell you that the square root of 44 simplifies to about 6.63. Let's try another one. What's the square root of 30? Well, again, it's not like 25 that's simplified perfectly. It's more like 44 that there isn't a perfect square root for that. So let's break it down. 30 breaks into 3 and 10. Well, 3 is a prime number. That doesn't break down any further. But 10 can break into 5 and 2. I'll cross off 10 because I broke it down. 5 is a prime number, and so is 2. So 3 and 5 and 2 are the ends of my branches. And now I'll look for pairs, but there aren't any this time. I just have a lonely 3, a lonely 5, and a lonely 2. In this situation, you just multiply all your lonely numbers back together and put it back underneath of the radical. In other words, 3 times 5 times 2, well, that's just 30. So the square root of 30 can't be simplified any further. The exact simplification of the square root of 30 is the square root of 30. But of course, we could also give an approximation for this. You could say that it is approximately 5.48, which you would get by typing it into your calculator. And last but not least, let's take a look at the square root of negative 11. If you were to type that into your calculator, it's going to give you some kind of an error, and that's because it's not possible to square root a negative number. Remember, the idea behind square rooting is that you have to multiply a number by itself to get to whatever's under the radical. And it's not possible to multiply a number by itself, the exact same thing, and get a negative. Because a positive times a positive is a positive, and a negative times a negative is a positive. There's no way to multiply a number by itself to get a negative answer. So, the reason I bring this up is because if you end up square rooting a negative number at any point during today's lesson, that would tell you that you did something wrong. You should never get a negative number underneath of your radical when you're working on the distance formula. So let's talk about the distance formula. The distance formula is a way to calculate the length between 2 points on the coordinate plane in units. In order to use the distance formula, you must first know the coordinates of each of your points. You can label one of them as x1 and y1, and the other one as x2 and y2, and plug the numbers into this formula, which essentially is just subtracting your x's and squaring it, subtracting your y's and squaring it, add those two numbers together, and then square root it. Let's take a look at an example. Now this first one is a horizontal line. Horizontal and vertical lines, you can just count. You don't actually need the formula. So from A to B, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Segment AB is 14 units long. But let's verify that the distance formula actually works by plugging in each of our points and simplifying. A is the point -8, +6. B is the point +6, +6. So let's go ahead and plug those numbers into our formula. So AB would be equal to x2, which is 6, minus, because that's what the formula says, x1, which is -8. So you'll notice here I ended up with a minus. Feel free to write that as a plus instead, because subtracting a negative number is the same thing as adding. Then I'll write a squared, because that's what the formula says, and a plus, because that's what the formula says. Now I need y2, which is 6, and y1, which also happens to be 6. So let's simplify. 6 plus 8 is 14. 6 minus 6 is 0. 14 squared is 196. 0 squared is 0. 196 plus 0 is obviously 196. And the square root of 196 is 14. So that verifies it. We counted that it was 14 units, and according to the distance formula, it's also 14 units. But let's try one that we couldn't count, like this segment. In order to use the distance formula to calculate the length from point W to point X, we need to know the coordinates of point W and point X. W is the point -2, -5. I'll call that x1 and y1. And X is the point 4, 3. I'll call that the point x2, y2. Now I'll just take all four of those numbers and plug them into my formula. x2 is 4, minus, because that's what the formula says, x1, which is -2. Again, feel free to write that as a plus instead of a minus. Then I'll square it. Then I'll add y2, which is 3, minus, because that's what the formula says, y1, which is -5. Again, feel free to write that as a plus instead. At this point, you can actually just plug the whole thing into the calculator. You don't have to show me all of the next steps. If you don't want to simplify step by step, feel free to just type it into the calculator. That's totally fine. But let's take a look at how this breaks down. 4 plus 2 is 6, and 3 plus 5 is 8. 6 squared is 36, 8 squared is 64. 36 and 64 gives me 100, and the square root of 100 is 10. So WX is 10 units long. Let's try another example. S is the point 3, -6, I'll call that x1 and y1. And R is the point -5, +4, I'll call that x2 and y2. Now you might be saying, hold on, Mrs. Goforth, I called R x1 and y1 and S x2 and y2. Am I going to get a different answer? No, you'll get the exact same answer as me. It doesn't matter which one you call x2 and y2 and which one you call x1 and y1. As long as you're consistent when you fill out your formula, it doesn't matter. So let's take a look. RS is equal to -5 minus 3, that's x2 minus x1 squared, plus 4 minus -6, or 4 plus 6, that's y2 minus y1 squared. At this point you can type it into the calculator, or you can simplify step by step. -5 minus 3 is -8, and 4 minus -6 is 10. Be really careful when you square a negative number, because if you just type in -8 squared without the parentheses, it's going to tell you that the answer is -64. It interprets -8 squared without parentheses as the negative version of 8 squared, and that's not what you wanted to do. You wanted to square -8. So do be sure to put parentheses around negative numbers when you're squaring them if you're simplifying step by step like I am. You should get a positive 64 when you square -8, and a 100 when you square 10. 64 plus 100 is 164, but 164 is not a perfect square. So we're going to have to make a factor tree. 164, well, I see that it's even, so I at least know I can divide it by 2. 164 divided by 2 is 82. 82 breaks into 2 and 41. I'll cross off the 82 because I broke it down. And 41 is actually a prime number. I know that's a pretty big number, but it is prime, so I've reached the ends of my branches. Now I look for pairs. I see a pair of 2s, and then whatever's left over, I like to underline it, and then I'll write my answer. If I had a pair, it's going to go outside, and if it's a one that didn't have a pair, a lonely number if you will, that one stays inside. So our S as an exact length would be 2 root 41 units. And if you wanted to type it into the calculator and get an approximate, that would be about 12.8 units. Alright, I want you to try this next one on your own. Go ahead and pause the video and calculate the length of segment FG. Okay, let's see how you did. G is the point 3, -1. F was the point 7, 9. So I'll plug those numbers into my formula. Square root of 7 minus 3 squared, that's x2 minus x1 squared, plus 9 minus -1, or 9 plus 1 squared, that's y2 minus y1 squared. Again, your numbers might be flip-flopped from mine depending on which one you called x1, y1 and which one you called x2, y2. You might instead have 3 minus 7 and -1 minus 9, and that's totally fine. You're going to get to the same answer as me. Simplifying step by step, I would have 4 squared and 10 squared, which is 16 and 100. So I find out that FG is the square root of 116, which unfortunately is not a perfect square, so we'll have to make a factor tree. 116 breaks down into 2 and 58. 58 breaks into 2 and 29. 29 is a prime number, so I've reached the ends of my branches. I see a pair of 2s and a lonely 29, so the exact answer for the length of FG would be 2 root 29 units. The approximate answer would be about 10.8 units. You actually don't even need a graph in order to calculate the length of a segment in the coordinate plane. You just need to know the coordinates. So I'll go ahead and label I as x1 and y1, and j as x2 and y2, and then plug the numbers into my formula. So 1 minus -4 squared plus -9 minus -3 squared, big square root over top of it, and let's simplify. 1 plus 4 is 5, -9 plus 3 is -6. Again, be really careful when squaring negative numbers like -6 squared, that is a positive 36. If you had written this as a minus 36 because you forgot the parentheses when you were squaring it, you would actually end up with a negative answer here, which would tell you that you did something wrong, because you would have done 25 minus 36, and that would have been negative, and that would have told you an error when you typed it into the calculator. So that's kind of a convenient way to double check yourself sometimes. But since we are smart and we know that we need to type those parentheses in, or just know in your head what -6 squared is, hopefully we're starting to memorize our perfect squares from Algebra 1, you'll have 25 plus 36, that gives you 61. Now 61 is actually a prime number, so that doesn't simplify any further. That is your exact answer. You could also write it as 7.8 units, which would be your approximate answer. Alright, you're on your own for this one as well. It's not in the coordinate plane, but you have all the information you need to know in order to calculate the length of segment TU. Give it a try. Okay, let's see how you did. I'll label this as x1, y1, this one as x2, y2, and here we go. You should end up with the square root of 45. No matter how you did it, you should end up with the square root of 45, which does break down. 45 breaks into 5 and 9, 9 breaks into 3 and 3. So I have a pair of 3s and a lonely 5. So the exact length of TU is 3 root 5 units, and its approximate length would be 6.7 units. And that's the basics of what you need to know about the distance formula. In our next lesson, we'll expand on this idea and do some more complicated problems as well as some word problems.